Okay, we want to review graphing by transformations. Here's the point -1, 1 on a graph of some function. That would be a basic point for a number of the functions that we've talked about, for the basic squaring function, for the absolute value function, which we didn't talk about for brevity, but you can read about that in your book, for a number of others. Okay, so we have a basic function. Let's just say maybe this is part of the basic y equals x squared function. We want to do a vertical stretch by factor -2. So what happens if we vertically stretch this point of the graph? If this is a point on a graph that we're vertically stretching by factor -2. Well, a vertical stretch moves the point that many times further from the axis. So what this does is it moves the point twice as far from the x-axis. Because what a vertical stretch does is it multiplies the y-coordinate by whatever the vertical stretch factor is. Okay? And it also reverses the sign. Okay, so basically we're multiplying our y-coordinate by -2. That's going to have the effect of stretching our graph by a factor of 2 and inverting it. So what's going to happen to this point is it's going to become 1, -2. It's -1, sorry, -2. Okay? So, and all the other points of the graph would stretch in a similar fashion. The further it is from the y-axis, when you double it, the further it has to go to double, and then of course we reverse the side of the axis. Now, we've seen pictures like this before. We haven't seen it with just one point, following one point through a series of stretches, through a series of transformations. Okay? Now I'm following the example, and I forget what the, okay, we're going to do a horizontal shift of 5 units. I'm staying as close as I can to the examples on the handout. So what's going to happen now to our point? Well, that means it's going to be shifted 5 units in the x direction. So instead of being at -1, -2, okay, which would be right here, it's going to shift over 1, 2, 3, 4, 5 units. To x equals 4, and of course it's moving in the horizontal, not the vertical direction, so the y-coordinate is going to stay the same, but the x-coordinate is going to be -1, I'm sorry, +4, easy to make a -1 into a 4, except the comma gets compromised, -2. Okay, so the point is shifting from here, where it was, over to here. I could show that up here too. The point was here. It's shifted down to here. So point's here. Now from here it shifts down to here, and then from here it shifts over here. 5 units. So it's 5 units horizontal shift. The next thing we want to do is a vertical shift of -3. So this graph goes through a vertical shift of -3. So we're at 4, -2. We're going to have to go down somewhat lower. So we start here at 4, -2, and we shift it 3 units downward. So that's going to move it here. Now my labeling is getting confused with my graph, but you should be able to see this point and understand that that's then the point for -5. Okay, so we've taken this point, we vertically stretched it. Now when you stretch, you multiply. When you shift, you add. Of course, if you shift by a negative, you add a negative. And that's the process. So that process takes this point to here, then to here, then to here. Now, what if we have 3 points? Okay, let's say the 3 points, 3 basic points of at least a couple of our graphs. Okay, so the points are -1, 1, 1, 1, and 0, 0. What's going to happen? Well, if we stretch stretch the graph by factor -2, that means we're going to multiply the y value by -2, but the y value is 0. So this point doesn't go anywhere with a vertical stretch. It ends up right where it was. And the point 1, 1, what does that do? Well, it moves twice as far from the axis, but on the other side, so it's going to move out to the point 1, -2. So after the vertical stretch, we're going to have points -1, -2. Yep, label it over here, okay. 0, 0, and 1, -2. Okay, here are 3 points. Now, if we horizontally shift these 3 points 5 units, what's going to happen? Well, the 0, 0 point is going to move over to 5, 0. Now again, the graphs are getting a little bit bunched up, but we can see the point, so let me label that 5, 0. 0, 0 shifts to 5, 0. 1, -2, this point is going to shift over 5 units. 1 and 5 is 6, so it's going to shift over to 6, -2. So here are the 3 points, here, here, and here. Now what happens when we shift up here? We're going to have a vertical shift of -3. So our point 5, 0 is going to become 5, -3. So let's extend the x-axis just a little bit here so we can get at least 5 and 6. So 5, 0, which would have been right here, is going to shift down to 5, -3. So here we have the point. That's a bad place to label it. 5, -3. Now this point here was drawn a little too heavy. This represents the point 4, -2, where the graph was, where it's being shifted to. My labeling 4, -5 is in a bad place because I'm going to want to draw the point 6, -5. So I'll change my labeling. 4, -5 is here. Now, 6, -2 is going to be shifted down 3 units, so it's going to go to 6, -5. Okay? Well, that should be clear. Okay? If this happens to be a graph of a parabola, y = x² graph, then the entire graph is going to look like this. When we invert it and stretch it by factor 2, it's going to look like this. Very similar, but inverted and also narrower because the y we've stretched it in the y direction. Okay, over here, the graph is going to have the same shape it had here, but it's going to have moved 5 units to the right. Vertex moves from 0, 0 to 5, 0. And these 2 points, well, you see where these come from. Okay, now over here, this point should be a little closer in here. We get the same graph, but now it's been moved down 2 units. So we stretch by factor -2, which doubles the height or the distance of every point from the x-axis. We invert for the negative, and we get this graph. And then we simply shift this graph 5 units to the right. Right here we are. The 0, 0 point goes to the 5, 0 point. Then we move it 3 units downward, so that the 0, 0 point, or the 5, 0 point now, goes to 5, -3, and every other point goes 3 units lower.